welcome back. We're talking about assembly language programming in the context of microcontrollers, and in this video we're going to look at program flow instruction example. So this example is going to use a conditional jump with the carry status bit C. And you might want to run this in CCS and step it through as we're going through it. I'm choosing not to in this example video, just to keep the slides flowing and keep the video brief so I don't have to type anything in. Now, if you're using CCS, then you might want to look at the memory browser and the register window again and step it through. So even though the program memory for the 6989 begins at 4400, you will see the program counter stores 440A, which is the first move instruction address when you debug this program and when you step it through. And the reason for that, actually, this is kind of cool, this is kind of important, is that if you remember that the CCS inserts two instructions before the main program, those instructions are labeled reset and stop WDT. There are also some directives, but the directives don't use program memory. So again, these two instructions that are labeled reset and stop WDT, these are actually going to take up program memory. And how much memory do they take up? Well, together, these two instructions take up 5 words, or 10 bytes, 10 addresses, that is. Thus, if we start at 4400, right, program memory, the next available address, if you do the addition, is 440A, which is where our program will start. Neat, right? And you can verify this actually in the memory browser. Open it up, search for 0x, so you have to put the 0x there to specify hexadecimal, 4400, and that's going to actually bring up the reset labels and the stop WDT label as well, and their words that they're storing. So again, that's a way to verify that, yes, that's where program memory starts, and those are taking up five words. Now, once we start stepping this through, then you will see that the first move instruction there stores, of course, the number 0 into R4. And the purpose of register R4 is going to indicate to us which jump we're going to take eventually here in this very simple program. And by the way, it is a simple program. You might be looking at it thinking, well, I could do this in a more optimum way. Yes, certainly you can. But the purpose of this video is not to be optimal. It's to be educational, to learn what's going on. All right, then those next two instructions, move and add, are going to add the numbers 254 and 1, and it's a byte operation, .b. So that's going to result in no carry. 255 is fine, right? And so that's going to keep the status bit C equal to 0. Now when the program counter keeps marching right along, right? And we're going to get to this JC, jump if carry instruction. It does exactly that, jump if there was a carry. So there is no carry here, C equals 0. So there's no jump. And again, the PC, the program counter, marches right along to the next instruction. Jump if no carry. Yes, so we have no carry. Since there's no carry, we're going to jump to the label that we've specified there, and that is carry clear. And if you're doing this, and if you're watching the program counter, you will see, it's a cool thing, that the program counter PC jumps several addresses. It skips the move and the jump instructions in the block carry set that we skipped. Of course, this move instruction in carry clear moves the number 2 into R4 now. That indicates that we are in fact in the carry clear block or routine. The next instruction, right, the program counter keeps marching right along, is an unconditional jump. Jump back to the main. So that will in fact happen. Because the program doesn't end, right? We don't want the program to end. So the program counter actually is going to decrease its value, and it's going to store the move address, right? And this again can be verified in the memory browser. You will see, if you're still searching around the address 4400, where main is in memory. And so you will see the program counter get, not reset, that's a bad word, but get decreased to that address. All right, now if you want to stop your program, if you're following along, go for it. Please do. And change the number 254 there to 255. Then debug, run, and step through. Now, when 1 is added to 255, and remember this is a byte operation, a carry is going to be produced. C equals 1, that is. So, when we get to the next instruction, jump if carry, it's going to jump to the address labeled carry set. The PC will jump past the address of JNC. Right? So again, you maybe want to take a look at that in the registers window for the program counter. Now here, since we're in the carry set routine, the number 1 is going to be moved into register R4, thus indicating that we are indeed in the carry set routine. Then the program counter marches right along, and then we get this unconditional jump back to main, which again, you will see that the program counter address decreases and stores the move address at the move address which is in the main routine. And again, that can be verified in the memory browser by searching for main. All right, that's all there is to it. Next time, we're going to look at another program flow example. Thank you.